Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Today we will learn about linear programming problems or LPP. So from here, before we try to answer linear programming problems, you need to know about optimum value of objective function. The objective of a linear problem will be maximize or minimize some numeric value. This value may be the expected net present value of a project, cost of project. It could also be the amount of wood produced or parking area and etc. The objective function is indicates how much each variable contributes to the value to be optimized in the problem. Okay, before we talking deeper about that one, we need to know about meaning of symbol. If the symbol is the first less than is equal with the lower than. And then if the less than equal is then the call is less than or equal to, or you say no more than or doesn't exceed or at most, and then have greater than is equal with the more than and exceed, and then greater than or equal to is equal with the at least or not less than. Okay, so from here you need to remember about the meaning of symbol, everyone. So from here we went to formulation of LPP based the problem. Okay, because in the previous video we are talking about that one based on the equation, based of the linear inequation. Example, let a manufacturer produce two types on the chairs, steel and aluminum. Processing of the chairs is done onto machine A and B. A steel chair needs 2 hours on machine A and 6 hours on machine B, and an aluminum chair needs 3 hours on machine A and 5 hours on machine B. The machine A can run 60 hours and then machine B can run 20 hours a day. The profit on selling a steel chair is 400,000 rupiah and aluminum chairs is 500,000 rupiah. Formulate the above as a linear programming below. So from this equation, you need to let up what the of the question. From here we have two type of the chair, so you need to let the steel to be X and aluminum to be Y, or you can use A or B, but it's easy for us, we let to be X. So from here, solution, let X equal number of the steel of chairs and Y number of the aluminum chairs. So from here, machine A, they told us steel chair they have 2 hours and aluminum chairs will have 3 hours. And machine B, steel chairs can be work in 6 hours and the aluminum chair is 5 hours. The total of the machine A is running is 16 hours, and then for machine B is 20 hours. So the profit of the steel chairs if they're selling is 400,000 rupiah and aluminum chair is 500,000 rupiah. So from the table, remember about the what's the key point in this equation. Okay, they are working not more than that hours. They just can run like 16 hours. They can just run for B, machine B is just 20 hours. So in here we have 2x plus 3y less than 16 hours. So they impossible if they are doing more than hours, more than 16 hours. So it's the same with the 6x plus 5y less than equal 20. So the two of this equation it's called constraints. Constraint is the meaning you change the sign from the equal to be inequality sign. And then for the equation for number 3 and the 4 is called non-negative restriction because it's impossible if the chair is minus, right? And then from here we have the purpose. The purpose is they want to have they want to formulate the above as a linear programming below. So when they ask about like that, you need to find the constraint and negative restriction and then the profit on this product too, because we already know from the question, if you can write fx or anything that you want, but from here I wrote fx, so it's equal for 100,000 x plus 500,000 y. It's called of this profit is the called objective function, everyone. So I hope you understand what I'm explaining. So example, a farmer owns 250 acre of land. He can use his land to produce rice and wheat. So from here you already have two things. You have rice and wheat. Total labor hours available to him during the production period of both commodity is 300. Each acre of rice production requires 2 hours of labor, and each acre of wheat production is require 1.5 hours of labor. If the profit per acre in rice production can be 800,000 rupiah and that in wheat production can be 500,000 rupiah, find the number of acres you should allocate to the production of rice and wheat so as to get maximum profit. Formulate the above problem as LPP. So from here, we have two things, rice and wheat. So from here, you can let rice to be X, wheat to be Y, and then the farmer have total 250 acres, right? So it's impossible if they have more than the acres, more than 250 acres. So you are ready to know, and then total labor of the production, but a commodity is just 300,000 hours. So from here we can let X allocates acre for rice and Y allocate acre for wheat. So we already know allocate area is just 250 acres. So it's getting impossible to more than that. So you can write X plus Y less than equal to 100, 250, 250, and then labor per acre. They told us in the example in the equation, they told us rice just can work labor per acre is just 2 hours, and then with 1.5, so they have working just 300 hours. So you can write here 2x plus 1.5 y less than equal to 100. So you need to always remember non-negative restriction is always be there. Okay, and then impossible, they are minus impossible. So we have constraint x plus y less than equal to 50, and then 2x plus 1.5 y less than equal to 300. So from here, we have profit. The profit, we can call it to be objective function. So fx is 800,000 x plus 500,000 y. So from here, you are already ready if you understand to continue to solving the problem, everyone. So now, in the above example of the objective function and the constraint are all linear. So it's getting impossible if the equation is quadratic is impossible. Therefore, it is a linear programming problem. So the two of equation I explained is LPP, everyone. So algorithm of the formulation of an LPP is as follows. First, you need to identify the variable whose value are to be determined and donate them. When you want to denote them, you can by using the first letter of the staff, or you can using x and y. And then the second, you need the identity of the objective function. In the previous slide, I explained about the objective function using fx, but in here you can using z or any alphabet that we have, and then identify the constraint. That's the meaning. The constraint is they have the symbol is less than or more than or equal than and etc. And then you need to put non-negative restriction on x and y, everyone. So that's the explain about formulating of the LPP, everyone. I hope you understand.